Hi, welcome back. Now in the screencast, what I'm going to show you is how to do to judge the regularization potential of the different size of hidden units in a neural network using keras and R. So in the last screencasts, we set up a subtrain validation split that I executed for a bunch of different neural networks trained with 100 epochs. The only difference between these neural networks are the sizes. So we did this for sizes, neural networks of hidden units from 2 to 1024, and we computed validation loss and accuracy values for each one of these neural networks. Then what we did is combine all the results into this single data table, which here I'm going to plot using ggplot2 in different panels. So here, as in the previous screencast, here we can see now what each panel represents here a different number of hidden units. Again, the plot is a plot of the validation loss versus the number of epochs. And here what we see is that for this particular subtrain validation split, well, it looks like almost all of the neural networks have not been trained enough. So we don't see really any evidence of overfitting in any of these neural networks. And so why is that? It looks like they're all, one thing that we see is that they're more or less all going down to about the same validation error values, which is actually kind of surprising, but there's a little bit of variation, right? So it looks like in the beginning here, after 100 iterations, the validation loss is a bit high, and then starts to decrease, and then it starts to increase again, which is actually to be expected because this is a regularization parameter. But so to more clearly see that, let's make another plot of these data, right? And so here we have this table units metrics again, and so what I'd like to do now is I'd like to add. So here, this is a plot of just the validation loss. I'd like to add a plot of the train loss as well. So let's do that. So the train loss is in this other column over here, loss. And to keep track of this information, let's do a melt operation using my NC package, capture melt single. What this is going to do is I'm going to melt all 4 of these columns into a single output column. So watch how this works. We're going to provide unit metrics, this data table as the input, and then we're going to provide a regular expression in the next arguments. This regular expression is going to be specifying the set, which is either let's see, it's going to be either val or nothing. Well, so let's say it's val. So here you can specify this as an optional an optional val. Perhaps it's easier to understand like this, val or nothing. I think that should work too. And then, metric will be either loss or accuracy. So let's see what happens when we do that. Let's call that unit metrics tall. And so yeah, when we do that, let me reformat that so it's easier to see. What we get is we get all of those values in the taller data table now with 4,000 rows instead of 1,000. Those 4 columns have been collapsed into this single column, and now we have different columns for the set and the metric values. And so here we can say units metrics tall capital set equals if else. set equals val underscore, then that's the validation set, otherwise it's a train set. So then we get this other table where we have an additional column that indicates what set. So if we want to make a similar plot, let's look at the ggplot code that we have there, and then let's add yval equals value, color equals capital set, data equals units metrics tall. And so we should have, that's again, so this is only, so this will be plotting the accuracy as well, right? So here we have the accuracy as well as the loss. So here let's just plot the data for metric equals loss. Let's see what that looks like. So here now we can see the train set, it looks like it's always, well actually for both sets it looks like it's more or less always decreasing for this particular, so actually to be clear, you know, we're talking about here, we should call that the subtrain set instead of the train set, because remember we split this train set into subtrain and validation sets. So yeah, so so here it looks like the subtrain set, again in orange, is always going down. Validation set is always going down here because we haven't gone to a lot of iterations. But so what I wanted to show you is that the regularizing effect of this, just the model size, right? So let's do that by just looking at the last data point. So here, to emphasize that, here I'm gonna cut this out and let's call this units loss tall gets units metrics tall for just metric equals loss, units loss tall. So again, this should be the same plot that we just looked at because we just renamed it as a variable. And so here what I'm going to do is units loss tall epoch equals max epochs. And so what I'm going to do there is I'm just going to have, let's call that units loss last. Okay. Epoch, yeah, right, it's not epochs, it's epoch, right? So what that's going to do is that's just going to be the data table of the last epoch. And what I'm going to do now is I'm going to plot that as a geom point, a units lost last. And so when we do that, we should see just highlighting that last point. And so what I wanted to show now is what happens if we just plot that last point. Right? So then we can examine the regularizing effect of the number of hidden units. So let's get rid of all of the other data points. We're going to make a new ggplot. Here I'm going to do geom line with AS epoch. And so here on the x-axis I'm going to put the epoch. On the y-axis I'm going to put the value. Again, this is a loss. And then yeah, for color let's do set again. But yeah, so actually here it's just the last epoch, so we're going to change the x-axis from epoch to hidden units. So now we're going to examine what is the regularizing effect of the number of hidden units. Data equals units loss last. So, and let's do scale x log 10. It's because our values are on the logarithmic scale there. And so this is kind of interesting, right? So what we can see is that we have a clear regularizing effect for the number of hidden units, right? So here what we're plotting is the loss as a function of the number of hidden units. And we can see that for this, you know, so the neural networks with the small number of hidden units are over here. The neural networks with a larger number of hidden units are on the other side. And what we can see is that, you know, these are like the typical kind of learning curves that you would expect for a regularization parameter. That is, you know, for the subtrain set, the the loss is pretty much always going down with a little slight variation up over here. But with the validation set, you can see it's going down up to a certain point, and then it goes back up again. And so you can see that this clear going down and then going back up again, this is the point at which the neural network starts to overfit with respect to this regularization parameter. So we can see from this plot very clearly now that the number of hidden units should be considered a regularization parameter, right? If we have too many hidden units, we're going to be overfitting, doing well on the train set but not on the validation set. And if we have too few hidden units, we're not going to do well on either the subtrain set or the validation set. So it's good to pick some intermediate value. And so for this data set, these data suggest that a value of, around, between 10 and 100 should do pretty well. Okay, so thanks for listening to this screencast.